Maybe I'll come back over to our announcements real quick. We were working on factoring last class and doing some rational expressions. We're going to continue doing today. And then we're going to finish off doing radicals and rational exponents and radical equations. This is from spring, right out of the pandemic, when like no one knew shit. They were all getting passed for no reason. And so I needed to make sure people knew it. And I spent a lot of fucking time. It like really slowed down the course, had to rush through shit later on. These are all 2-hour videos with a lot of fucking examples. So if this is too fast for you, what we're doing, these are resources where you can go watch some shit more that's at a slower pace. You can also check out our textbook. God damn it. John Blakely, and look at the previous chapters. Chapter 4 was on factoring. Chapter 5 was on rational exponents. And chapter 8 is on what we're doing for the last part of today. And that's if you don't want to walk through, like skim through a video, you can skim through the text and say, oh, do I know this problem? Because he walks through and explains how to do it pretty well there too. So that's a quicker spot to get some review there. Megan did not like me talking about her tank top or her turtleneck last time, and so she fucking completely changed that.
There's like this weird turtleneck thing that you can get, that it just has the turtleneck and then it has like a square piece.
So you stick it underneath your shirt?
Yeah.
I need that. I don't know. I don't need it, but it sounds like I need it. All right. Where did we leave off? Let me, I'm pretty sure I know, but I can come look at my module notes. Ah, that's something else. In our modules, if you're just clicking on doing the homework from over on the home screen, where is it? Let's do student view. If you're just, motherfuck, let it go. I guess it's not, the home screen doesn't show it. Oh, good. Well, I'm glad I have it set to modules. I guess I can leave student view then. That's annoying. Lecture content, as I make these videos, I put them up. And as I write these notes, when I leave class, I go scan them. This was from Tuesdays. And I'm just gonna fucking scroll down and see what the last thing I wrote was. That seems like a pretty good way of figuring out where I left off in my notes. And I think I know it was, we just talked about doing division. Fucking today, Junior. Whoa, that's fucking supersized font. Are you shitting me? This is ridiculous. This is not helpful. It's too fucking big. Oh, we talked about doing adding and subtracting. We did division there, we did adding and subtracting. All right, excellent. So, math 35. Lecture day 4. We are going to wrap up R5 on rational exponents. And we are going to cover R6 on radicals. Where we left off, we had done some addition and subtraction. We didn't give you, let's go harder problems in the rational, not rational exponents, rational expressions. Harder radical expressions. Fuck, rational expressions. This is fraction inception. Fractions and fractions. Looks busy, right? Looks like a pain in the ass. There are several ways to do this. You can get common denominators on top and bottom and then do, this is a fraction divided by another fraction. And we could do the reciprocal, but there's an easier way. Find the LCD of all the inner fractions. Inner fractions being not the big bar. Everything that's above the big bar or below the big bar. So on top, I've got x and x squared. And on bottom, I have x and x squared. And the LCD is going to be x squared.
Why is it x squared?
Because if we do the factorization of them. Oops. One thing is we do one from each column. The other is, this is LCD is least common denominator. So we're looking for some term that all of these divide into. So x squared is divisible by x and x squared. The same way as if we had denominators like this. We're looking for the smallest number that we can divide all of these into. One way of doing this would be write down all of their factorizations. And doing this little column table that I was showing you. And one from each column is 3 times 5 times 2, which is 30. 30 is divisible by all of these, and it's the smallest number that is. 60 is also divisible by these, 90 is divisible by these. The same way up here, multiples of x squared are. I could have x to the 4th, I could have x to the 6th. That make sense? Okay. All right, so we got our LCD. What we're gonna do is we're gonna multiply top and bottom by that value, and we're gonna, since it's a fraction, we're gonna put it as over 1. What I've done here is I have multiplied by x squared over x squared. What is any number divisible by itself? Divided by itself. This is 1 as long if x doesn't equal 0. We can't divide by 0, but any other number this works. But there's no equal sign here, so there's no worry about x equaling 0. We know x can't equal 0 because it's already in the denominator. It wouldn't be in the denominator if it could equal 0. So we're effectively multiplying this fraction by 1. And what happens if we multiply anything by 1? Nothing happens. You end up with the same number as before. So multiplying by this is like multiplying by 1, and it doesn't change the value. It just rewrites the value in an easier form to read. In our case, it will allow us to clear fractions. Let me rewrite this down here. What's a minus? I'm gonna distribute this to each of these by putting an x squared on top. Multiplying it by an x squared on top, I should say. Just the same way as I'm technically multiplying the bottom by 1, but that's not doing anything. So I do that down here, I hit the numerators down here. And the first thing we've got is 7x squared divided by x. One of the x's goes, and we get 7x. On bottom, we have 4x squared divided by x squared. The x squareds cancel here, which is up -4. Well, -4/1 is what that becomes, but 4/1 is just 4. If I clean up the bottom, what should I get on bottom? 3x plus 8, right? Now, I could look to see if anything simplifies more by trying to factor anything out. But like 7's a prime number, and so is 3. And so those aren't factoring anymore. And some of them have x's, some of them don't, so nothing cleans up here. So that's actually the simplest form. This is gonna get ugly. X minus 3, I can't break apart. I can't treat the x and the 3 separated because they go together. So like, if I were to do my table, I would have an x minus 3 column, an x plus 3 column, and an x minus 5 column. So the LCD is literally all of them multiplied together. That's what I'm gonna multiply top and bottom by. And since it's a lot of shit to write, I'm just gonna say we're doing it there. I don't recommend multiplying shit out. Because you want it, we're doing this so that we will cancel out ugly shit. If I distribute that, if I do all of this times the first one, the x minus 3 cancels, but I'm left with x plus 3 and x minus 5. Does that make sense? If I multiply this first thing by that, the x minus 3's will cross off, and I have the rest. The 5 has nothing in the denominator, so it gets all of them. The bottom, x plus 3 cancels, and I'm left with x minus 3 and x minus 5. And here, that's a minus sign, minus 8, The x minus 5 cancels, and I'm left with x minus 3 times x plus 3. Wouldn't it be nice if we were done? We're not. We have to clean it up because it may simplify. Cleaning it up means multiplying all this shit out. So if I multiply that stuff, x plus 3 times x minus 5. I have x squared plus 3x minus 5x is minus 2x there. And then minus 15. And I've got plus 5 times. I'm going to cheat and do a little bit of this up here. This is the same as 5 times x minus 3 and x plus 3 are like the difference of squares. That turns into x squared minus 9 times x minus 5. And now when I come down here, I'll multiply that out. X squared times x is x cubed. X squared times -5 is -5x squared. -9 times x is -9x. And -9 times -5 is positive 45. There's a lot going on there. If I do this down here, I should get x squared minus 8x plus 15. And that's x squared minus 9. Fuck, Jones, this is fucking rough. There's a lot of shit going on here. All right, let's distribute and try to combine like terms. I'm going to try to do this in one step. So on the top, there's only one thing that generates an x cubed, right? For x cubed, I got to do this one. So 5x cubed. And then for x squared, I have 4x squared and minus 25x squared from distributing. So putting those together, I get negative 21x squared. And that dealt with that term and that term. And now I have a couple things with x's. I got 4 times negative 2x is negative 8x. And 5 times negative 9 is negative 45x. Together that makes negative 53x. And finally, I'm down to just whole numbers. 4 times negative 15 is negative 60. 5 times 45 is 225. So together, that's 165, I believe. I'm doing that in my head, though. 5 times 45 is 225. Yeah, that's correct. All right, then we do the bottom. We're gonna look at the x squareds. There's a 9x squared and a negative 8x squared. So just a single x squared, right? Then I have only one spot with an X right there. 9 times -8 is -72x. And then 15 times, oh fuck, this is a lot. 9 times 15 is 90 plus 45 is 135. And -8 times -9 is 72. So that's 207. Now, I don't know if the bottom factors, it might, we haven't talked about how to factor the top yet. That's way later in this course. So as of now, we're gonna just say that's as done as it's gonna get. Okay? We will learn how to try to factor this top later on. We will learn how to do this. You just say fuck.
Yeah, I remember part of how to do it, and I don't remember the whole thing. For the top, do you group it, and then,
What do you mean?
like, if you wanted to factor the top of that,
You can try,
you could try, but you won't get it.
but you might be able to get it, but it's not always like a whole number. Sometimes it's a fraction. You might have like 1/5 or some shit like that. And we'll talk about how that works later on. In terms of the midterm, shouldn't be anything this difficulty on the midterm. This is fucking pretty complex. But if you can do the complex shit now. And on the homework, that means the easier shit, the test should be easy, because it'll be easier than this, right? Do the hard stuff at home, do the easy stuff on the test. I'm a firm believer in that. Just a matter of time issues. You only got so much time to take the test. If I want to do hard problems, I can't get very many, and that just means failing all my students. Effectively. Other than those that just like really get it. And that's not beneficial to anybody. Bad industrial, no one's very well, or anything like that. All right, that was a lot. Let's talk about rational equations. We haven't done any equations yet. I'm gonna show you the correct way to do this. And then I'm gonna show you the easy way to do this. The correct way matters because when we have inequalities. We have to solve them we can solve them the same way, but we gotta do the correct way. The easy way doesn't work on inequalities. So I'm gonna show you like the way that it always works, regardless of the symbol. And then we'll talk about if it's an equal sign, what's the shorthand. So the correct way is get a common denominator. For this problem, that's relatively easy. These are already both x plus 3. So I just need to multiply this by x plus 3 over x plus 3. So now on the left, I have x over x plus 3 plus, and I'm going to distribute that here, 3x plus 9 over x plus 3 equals -3 over x plus 3. And when denominators are equal, we can combine fractions as they are. This just becomes 4x plus 9 over x plus 3 equals -3 over x plus 3. Now, this says they are equal. Two sides are equal. The bottoms definitely are. They're identical. They both say x plus 3. So for this to be equal, since the bottoms are equal and this whole thing has to be equal, this kind of forces the top to be equal. So this becomes 4x plus 9 is the equivalent of having that. Another way of doing it is getting them all, another way of doing this is if I add the fraction to both sides, like I collect everything on one side. I get a 0 on the right. And I get 4x plus 12 over x plus 3 equals 0. And the only way for this to equal 0 is if the top equals 0. That's how fractions equal. A fraction equaling 0 means the numerator has to equal 0. And this is the same thing as 4x plus 12. I just moved the 3 over. Here, I wouldn't move the 3 over. I would, starting here, subtract 9. Divide by 4. And I get x equals -3. But there's a problem with that.
What if the denominator be 0?
It makes the denominator 0. So if you're looking at that right here, in the last simplest form, I plug it in up here, this makes the denominator 0, which means I can't use it. No. Let's cross that shit off. So there's no solution. There is no number to plug into this equation that'll work. Now, the shorthand form, I'll let you finish writing that. Shorthand form does the same thing. We're going to find the same answer. It's in fact a lot shorter. But it doesn't work when there's inequalities. And I'd rather teach you how to do it right. And then use shortcuts when you can. Do you guys know about the COS giant threads? Giant threads, if I remember when I remember, I'll post a link to like a video of it so you can see it. Every student at COS is entitled to a full outfit once per semester. You gotta like make an appointment to go in. They're only open on like certain times. But you can go in, you can get a new shirt, tie, like something you would interview with. And you know, it doesn't have to be stuff you would interview with if you don't want. You can go get a full outfit for free once per semester. The person in charge of the fashion department has teamed up with. Like department stores for like clothes that may not necessarily sell, or she'll go bargain shopping with funds. And buy and like fill it out, it's got clothing for men, women and unisex, so. Like if you like, if you're a guy and but you prefer wearing female clothing. There's no judgment in there, you walk in, get what you know, go to the unisex section, pick what's good for you. I think it's only open on Wednesdays though. I will post a link to the information, a video to it if you're interested. But a free suit or free outfit every semester, that's just not cheap.
Yeah, I was gonna say suits are another thing entirely.
Now, it's probably not a suit and a jacket. But I'm sure they do a good button up, a tie and slacks or something like that.
You get to keep it.
You get to keep it.
Really?
It's not a rental, it's not a borrow,
Threads, but I thought that it was like a rental.
no,
Then you get no.
keep it.
Yeah.
And if they don't have like a size that works for you, like for me last semester when I did it, we actually went to a store and tried on. Clothes.
Nice.
Because like, she could try to order stuff, but it's easier like, if they don't have something that fits you,
That's good to know.
that they'll take you. You get a schedule and.
I will add that to my announcement when I put it up.
Wait, I thought that it was like training for people to tailor.
When they first, no, well, the fashion department is for fashion, that's,
Yeah, that's.
but like. She's expanded the service to serve the community here. And I really like that, I didn't know that, and I don't know that it says that in any of the video
It
either,
wasn't, but when I went, we couldn't find a size that.
right?
Like fit me particularly well. Cause like when you're interviewing or using whatever you're using this outfit for, you wanna be comfortable, so.
If you don't have the normal dimensions, either you're too wide, too thin. Or a proportion of the two, like if you're large but thin. Tall clothing is generally meant for wide people. Like big and tall, they go together. I don't, I'm just big. I'm big and small. They don't have a big and small store,
Big and short.
right? They need it.
Yeah,
So like, and they don't, so they don't have really tall and slender, and they don't have short and fat. Short and wide. There's,
That's
well, I'm referencing myself here, so
all of ours.
that's good. You wanna call me stout. You go call me fat, that's a quick F, that's right. Alright, so, quick way. And what you should probably pretty much do, as long as there's no inequality. What does everybody say, the fractions? Buck fractions. But. Make a note. It's called domain violations. Where the bottom equals 0. So I'll do that right here. I only have one denominator. Where the denominator equals 0 is x plus 3 equals 0. If I solve that, x equals -3. And since that will make it equal 0, I just gotta make a quick note. That doesn't work. Bad juju. If it shows up later on, we gotta throw it out. As we know, it shows up later on. Other than that, when we say buck fractions means clear fractions. By multiplying by the LCD. Yes,
What does it say under domain violations? But.
bottom.
bot equals 0. Cause I was that lazy to not write out bottom. I shortened denominator to bottom. And I'm like, it's my little T-Rex arms is too much work.
Try to simplify it.
Now here, there's only one denominator, it's the same thing on all of them, so this literally means just multiplying by x plus 3. On the left side, the x over x plus 3 just clears the fraction. I have x. The 3 doesn't have the denominator, so it gets it on top. And the right side just clears the fraction. I'm left with -3. Okay. Distribute. All right, start cleaning up. We already know how to solve this stuff. It's a bad juju solution. So we cancel it and we end up with no solution. Yeah,
What if the solution we got was in a different equation, not taken? Like if those two numbers weren't the same.
then it's a valid solution.
That's-
Like if we had like x equals -5 is bad, but we got x equals -3, that's fine.
that's-
Or if we got like x equals -2 here, it doesn't make the bottom 0, so it's fine. Does that make sense? I'm thinking there's no way I'm gonna finish R6 today. Which means I'm pushing that homework. I might have to just adjust the whole fucking schedule rather than try and play catch up. And making a video, adjust the video schedule. Cause we got review days planned in, but I can just like. Give you an online review and. Make a video for you, a review at home. And just give you extra time to do the review and work the schedule around and not miss any content, but. Still get the shit taught. Which means I don't need to rush through this.
0 with line code signifies no solution.
That's valid. I like that.
Yes.
This usually means empty set. So the set of solutions is empty. That's some math jargon.
Would that be okay to put the?
Yes,
So you could just put x equals 0 for line 3.
no,
Just 0 with the line.
just 0 through a line of it.
You literally.
That's not the same thing. Don't do, I'm glad you brought this up. Don't do x equals that.
Isn't it saying that?
This is saying x equal, this is, for some people, that is saying, is equivalent to saying x equals 0. That, a lot of people do that to separate that from O's. So don't do this. This is okay. Just putting the circle with the line through it.
And that only, this method only works for the equations, not inequalities.
Correct. inequalities, we need to keep that X plus 3 in there. Because it affects the regions that are valid, as you'll see when we do inequalities. Which is not today. I don't know when it is. Guys ready for more? See pins moving, so I don't know if you're just like making personal notes or still writing what I'm writing. Does anyone need to have longer? If you do, say something. Otherwise, if you're not willing to speak up, you're out of luck. All right. Since we've got time to go through and do this justice, let's do this section justice. And give you some word problems where where this shit matters, or like where it not matters, but is useful. We still want to clear the fractions or get a common denominator, which is the same thing. You got to get the common denominator before you can multiply through by it. So it might be easier if we factor the left side first. Because you'll see. If we factor that, this is x minus 2 times x minus 4. Those two are equal. Which means that is my LCD. Because this is in it. And this is in it. And the right side is already it. Does everyone follow that? Near giant threads, there's also the giant pantry. Which is like fucking free food. Like grocery, like you can get canned fucking shit and stuff like that. You don't want fucking free threads? You're just assuming it's shit clothing, aren't you? It's not, they're not worn clothes, they're all just.
Oh, I'm sure it's not, but I'm just, it sounds like.
He's too good for it. You're less because you like to eat. I'll get out of that. Alright. So. If I multiply through by the LCD, I'll put up info on the giant pantry too. What happens to this first term? What cancels?
X minus 2.
The x minus 2 cancels, which leaves behind what? It leaves behind the x minus 4, which is multiplied by what's on top, the x. Does everyone go with that for the left one? What about this next one?
States.
X minus 4 goes, the x minus 2 stays. I'm gonna write the 1 just to show that it's there, but it's not really gonna change anything. What about the right side? It's just 2. Before I go further, I wanna mark down, what are my domain violations? Domain violators.
X minus 2.
If I do x minus 2 equals 0, I get x equals 2. If I do x minus 4 equals 0, I get x equals 4. So those two are domain violators. Those are the bad juju. I need to look up and make sure that's not like slang for something. I hope to God it's not. I hope I'm not saying some racist shit or something stupid. You'd be surprised what common fucking phrases. Have you guys seen the fucking Carl's Jr. or is it KFC commercial? There's this guy, young man, And a young lady sitting in a car with KFC. And it's dark, they're in a parking lot. And the commercial leads with, you want to smash? Try this smash chicken bowl. It's like chicken and mashed potatoes. I'm like, really? Cause if you go, we should be changing, that should be like, what you're saying, your commercial says, do you wanna fuck? Buy KFC. That's what it says, and yet they're labeled to legally do it because smash isn't the F word.
They know what that was doing.
Holy shit, what you can get away with an advertisement today. My wife didn't know that expression. She's not around young whippersnappers like you guys, like I.
What is it, like smash or pass?
All right, what do we do here?
X squared minus 4x. Plus x.
Group, all right.
Add 2.
Okay. I added 2. Didn't help.
Supposed to subtract 2.
Supposed to subtract 2, so that was bad.
Yeah.
So let's change that, let's do subtract 2. And we'll have x squared minus 3x minus 4 equals 0.
That's what I'm gonna say.
Wrong step. So let's do the correct way. Why was this wrong? We wanna, when we have a square thing, we wanna be able to break it up into factors and use that 0 factor rule. Because where can I go with this? I mean, on this one, I could factor out an x, but that's not really helping me any. So here, actually, this actually helps though. That is x minus 4 times x plus 1. Right? Am I doing that right?
Yeah.
So that is, says x minus 4 equals 0 or x plus 1 equals 0. And when we solve, we get x equals 4 or x equals -1. Why do you say that, James?
X equals 4 is bad juju.
X equals 4 is bad juju. That's right. So cross that shit out. Our only valid answer is x equals -1.
Isn't x equals -1 also the solution if we just, like, if we were checking for domain violators, we could also check x plus 1, right? Because that's technically a hidden.
Yeah, x equals -1 would be x plus 1, but we don't see it in the denominator up top. And really, that's really the only problem is when the bottom equals 0. We don't want any of these fractions to have a bottom equal to 0. X equals 4 does not make this 0, but it does make that 0, and it does make that 0. It's a little bright. Does that make sense? Are we having fun yet?
Yeah.
Megan, are we having fun yet? You're such a good liar. It's a lot of work, but it's not necessarily hard work. Once you understand how to do it, it's not like. Art can be a fucking lot harder. Picture doing shit with fine fucking detail. Like really fine fucking detail. And you need like lines that are fucking thin enough. Where pencils are like, I think my pencil tip's too fucking wide. Art can be as detailed as that. That's just fucking hard. Painting miniatures is fucking hard. Cause it's really easy to fucking get that paint all over the fucking place. So. I would argue art is harder than this. I never made that argument before and I like it. No, I don't. Now it makes it sound like artists are better than STEM students and my ego will not allow that. All right. The following is called a literal equation. They have lots of variables. But we tend to solve for just one. So in the following, I'm going to say solve for P1. P equals N, oops, I already fucked it up. P equals N times P2 minus P1 minus C. When I say solve for P1, it means this bad boy is the only one we want. Isolate that bitch. Get it alone. You're probably belong in jail because you like to roofie your fucking prey. Get that P1 alone. That sounds, that's too far. I think maybe that's too far. You're a fucking lion. You're a panther. Get that weak fucking animal, isolate that herd member. That's better.
It's a better analogy.
It's better analogy. The other one sounds like I'm encouraging fucking crimes. And I don't want to do that. Don't do crimes. All right, so to do that, like we can pretend N, P2, and C are just numbers. Like if I had P, oh, and P. If I had 4 equals 3 times 2 minus P1 plus or minus 1, what will we do? We could move the 1 over. In this case, that means move the C over. And if I did that over here, like. Now on the right side, I could distribute the 3. And I could do that here, but it's less helpful. Ah, fuck it, let's do it. I would do it over here. I'm gonna do it over here. I would say 5 equals 3 times 2 is 6 minus 3P1. Over here, I will do the same thing. P plus C equals distribute the N, NP2 minus NP1. Here I would subtract 6. Over here, the 6 is in the same spot as NP2. And we're over on the red stuff, I can combine everything. Here I can't. That sounds a little bit like Christopher Walken. A little bit. I enjoy myself. And on the right, I would divide by -3. To get P1 by itself. Here, that's dividing by -n. So I get P1 equals. It looks a little funny having the negative down there. Alternatively, we could write the negative out front. And believe it or not, this is suboptimal. Because a lot of people, when you're writing, you write that negative really close to the fucking fraction. And when you look at it, it kind of bleeds into it and you don't see the negative sign anymore. The better choice is distributing the negative on top. Which literally just changes the signs of everything. I could put NP2 minus P minus C over N. It's already fucking 4:10 and I didn't give you all a break. Let's take a 5-minute break or so. So where is another spot these little equations kind of come up? AX plus BY equals C. Or like 2x plus 3y equals 5. Oftentimes, what would we solve for here? Anyone remember what we solve for in something like this?
Why?
Solve for y. Because it's easier to graph, as we'll see when we get to that next week. The same idea happens here. If I use generic letters, I could technically solve this using this. Subtract the AX over. And divide by B. Or you can have it as all one fraction, depending on how you want to do it.
We uploaded last week's video.
Yeah. Oh, why did I hit me? What the fuck's going on?
Broke it.
I did. There you go. If you're looking for the videos, just check modules and they're in the says lecture content through the midterm, links to YouTube. I think I actually have it set where it actually loads directly in the browser. But you can also just go to YouTube and look for Professor Hefe. But also whatever I scan, you can download a file and really if you want to like compare notes later on. So another one that might be familiar to people is this. Well, this is missing something to make it look familiar. Fahrenheit to Celsius. So if I wanted to know something in Fahrenheit and it's already in Celsius, I just plug it in. But what if you're one of those losers like the entire rest of the fucking world that doesn't use Fahrenheit and you like Celsius? This isn't all that helpful for you. I mean, you could do it one at a time for every single Fahrenheit, or we could subtract 32. And get degrees Fahrenheit minus 32 equals 9/5 Celsius. And then rather than dividing by 9/5, I'm going to multiply by the reciprocal. So C equals 5/9 F minus 32. And now that's a usable formula if you're like, oh, it's 105 in America. What are they bitching about? That sounds really fucking, and the Celsius is, that's really fucking hot. 105 degrees Celsius is fucking really fucking hot. The other way would be more like, why are they complaining it's 32 degrees? 32 degrees here is fucking 0 on the Celsius system. But on 32 degrees in Celsius, it's fucking hot. It's really fucking hot. Yeah, it's summertime. So like if we're saying, oh, it's fucking 34 degrees outside, it's fucking cold. And everyone else is like, put some fucking, take your clothes off, and you put some sweatshorts on or some shit. It's fucking hot. All right, yeah.
Is that the only formula to get degrees Celsius or Fahrenheit Celsius or Fahrenheit degrees?
This is the one I know of. Is there a different one that you know of?
Well, we use a different one in chemistry. Is
That's true.
We don't use the one with the 9/5, it's like.
Would you rather use 1.8?
Yeah, I mean, either way.
I was just asking like the.
Yeah, there is a different one.
There's a conversion.
Yeah.
There is F equals 1.8 C plus 32. But 1.8 is 9/5.
Oh, well, yeah.
So no, it's the same equation written with decimals rather than fractions.
Okay. Cool. Thank you.
Yeah. All right. Now. Why do I give a fuck about this? Mark and Jaden can paint a house, they're painting the house together. And it took 12 hours. Yeah. Mark had painted it previously. Alone. And it took 18 hours. How long would it take Jaden to paint it alone? Well, if it takes 12 hours together, it reasonably should take longer alone. The question is, does Mark Jaden work faster than Mark, or does? It's hard to tell. So. There's a formula that we do rate times time. Equals portion completed. Or R times T equals PC. So I'll make a little table. So if Mark takes 18 hours to do the whole building. In 1 hour. Mark. Does 1/18. We did 1/18 every hour, assuming he works at a steady pace. No breaks, no nothing like that. His rate is 1/18. Right, well, you could look at it as one house over 18 hours. Does that make sense? Javen, we don't know how long it's gonna take, but he'll do one house in X hours. Well, they were both working for 12 hours. So if I multiply this by 12 hours. Hours cancels on both of them, and I'm just left with the portion of the house that they did. So in 12 hours. Mark can do 12/18. Which simplifies to 2/3, but I'm not gonna simplify it for now. Alright, so same thing here, they're working for 12 hours, which means Jabin does 12/X. And the units here are houses. Because this was house per hour. House per hour. And multiplying the hours cancel out, I'm left with that. How can I work with these two pieces of information, this information? If they're working together, what should I do with this kind of information? You add it, which might be a little confusing when you think about like fractions. Think about it with not fractions. Let's just say. Mark can eat 12 bonbons. And Jabin can eat X bonbons. How many bonbons do they eat together? 12, you would add up how many they ate. Well, we can do the same thing here, we can add these up. 12/18 plus 12/X. Well, if we're adding them up, that's the time it took them to do one whole house. This should add up to one house. Because they painted the whole thing, so it should add up to one.
So then. Know that the remaining amount from 12 18ths, we know that the remaining amount should be 6 18ths. Because we already know the proportion from Mark did,
Yes,
so we have 12. So it's, so we can just kind of patch that together, yes.
we could. Where you're going is actually one form of dealing with this. What you just did in your head is you said this is. How much did you say was left over?
It was 6 18ths.
6/18, which you would actually get if I treat this as 18/18. And I subtract 12/18 from both sides. I get 12/x equals 6/18. Right? Okay, that's a valid way to do this. You could also clear fractions straight from the get-go. This is probably actually easier. As long as you're comfortable doing a little bit of fraction work right here. But we're gonna have to do fraction work anywhere in some form or another. Actually, not really. I could just multiply by 18x right here and clear the fractions. We'll look at that in a second. So we've got this 12/x equals 6/8. Does that make sense what I did there for everybody? What Davis did in his head? What he did reasoning and. Now, there's a couple ways forward with this. You might remember cross multiplying. So you cross multiply. When you have two proportions. So we had 12 times 18 on the left, 6 times x on the right. Now, I could multiply by 12 times 18, but I'm going to be dividing by 6 in a second to find out what x equals. And this is a hell of a lot easier to divide by 6. 12 times 18, 18 is 6 times 3. So my 6's will cancel. And I get 12 times 3 is 36. X equals 36 hours. So Mark works twice as fast. I randomly pick numbers here. People I played D&D with is Mark and Dave. I just sent a picture of the problem. I didn't know what the answer was gonna be. Now I'm gonna send a picture of the answer with it. Another way of doing this without doing that. Without cross multiplying. If I can get the tops to match, the bottoms have to match. We argued that a little bit ago, right? 6 times 2 is 12. So then I'd have 12x equals 12/36. Tops match, bottoms match. And the other way you could deal with this. Is to clear fractions. Multiply both sides by 18x. what happens with this first set?
Farm canceled.
The bottom cancels with the 18. I still have the X, so I'm gonna have 12X there, yeah, that's right. What about on the next one? 12 times 18. What is that? Let's see, if I did 12 times 20, it would be 240. Subtract out a couple 12s. Subtract out 216? 216. Equals the right side is 18X. So I can get all my X's on one side. Divide by 6. X equals 36 hours again. No, it took them 12 hours to work together.
Oh, my God, it's 36. James, just like, shitty word, James. Yeah.
You get mad as fuck when I show this. They're married and Javen is the one that like is neurotic about cleaning everything. Javen would more likely be the one that works faster. I just fucking picked numbers when I did this. I was actually their wedding officiant. They said, "You're an atheist, you'll make a good wedding officiant." Knowing I did, they're not religious either, so. Got a little like license to marry people.
That's like the officiant is the person that marries them.
Yeah. They're all fucking taller than me. Jamin's not, Mark is. Jamin's only like an inch taller, Mark's a lot taller than me. And so for every single one I play D&D with is all taller than me. And so for the wedding, after everything was done, they like, when we took a picture together, they knelt. It's the only picture where I have where I'm taller than them in the picture. At D&D, everyone's the same fucking height. All the height from your legs goes away. They fucking love that. Cause you don't really notice it because you're not standing next to each other. And when we all went out to like Chipotle one time, we're fucking standing in line and we're talking and I'm like this. I'm like, fuck you guys. Cause one of them just started snickering that my head tipped up.
So are you ordained, Mary? Are you're ordained somehow at the state of California?
Universal Life Church.
You guys get it on.
You get it online.
No way, really? Oh.
It's a legit thing. I have a card in my wallet. It's probably all faded as fuck. This was gotta be 2007 or something. It's been a while. All right, next problem. Canoeist can paddle 7 miles per hour in water, still water. In a flowing river, it takes the same amount of time to go with the current 30 miles as it does to go against it 12 miles. This is someone that rode downstream for a certain amount of time and tried to fucking row back the same amount of time and found out they weren't fucking home yet. How fast is the current? How long were they rowing? Or paddling? I take a picture of the rest of these. Javen says, depends on how long the guy I hired takes. Cause I always talk to the question. That's fucking funny. James said you're a slow fucker when it comes to painting a house. Alright. So what's going on here? Well, there is an equation that's related to distance and time and rate. Distance equals rate times time. Or if we divide by t, rate equals distance over time. Which is something you're probably more familiar with. Like when we say you're going 7 miles per hour, you are going 7 miles in 1 hour. Distance over a time. So working with R equals D over T isn't helpful though. This one's a little bit more helpful. So let's look at R times T equals D. And we're gonna do like with current. And we'll do against current. Some things are easy to fill in. Going with the current, they went 30 miles. That's under my distance block. And against the current, they went 12 miles. We don't know how long they went. So let's just give it a variable and let's stick with T for time.
Could it be T1 and T2 or no?
Since it's the same going either direction, we don't need to do that. That's a good observation though. If it didn't say the same amount of time, we should maybe call the top one T1 and the bottom one T2. But since it's the same, T1 equals T2, we can just use the same T. Excellent observation. If you're going with the current, like let's say the current was like 10 miles an hour. How would we figure out how fast we're going? If we paddle 7 and the current's going 10.
Times 10, 7.
You don't multiply them. You don't divide them. You add it. So if you're going 7 and the current's going 10, you would go 17. We don't know what the current's doing though, so I just made up 10. So maybe like, let's just use C for current. Back against current. Subtract, right? The current's working against us. So here I get 7 plus C times T equals 30. And I get 7 minus C times T equals 12. If I solve for T, I know the T's are the same. These two are the same. So if I solve for T, this says T equals 30 over 7 plus C. And this T says, divide by 7 minus C, I got 12 over 7 minus C. And since these two T's are equal, that means these are equal.
So we plug in one of those versions in to T and solve.
Yeah. Wait, say that again?
So we could solve, we are not solve for T, but solve for C. You can solve for C by substituting.
Well, we can focus on these two. And solve for C. Let's ignore for T for now. We'll come back to T in a second. Since these two are equal, we should be able to solve for C, right? Does that make sense?
Do that.
Well, what did you want to do?
I just was saying, I'm doing it the hard way, I'm thinking,
Probably.
taking one of them, plugging it back into the first version of the problem.
Oh, like taking this and plugging it in there?
Where T is. Yeah.
Well, you'll still end up getting this, believe it or not.
We're still gonna get.
So yeah, you would be doing it the hard way, but that would be a valid approach. So I got 30 over 7 plus C equals 12 over 7 minus C.
Of 12 instead of 17.
I suppose, if you must insist,
I want to be stuck without a paddle.
right? Why is the expression up shit creek without a paddle? That's not a big deal. Because if you're up the shit creek without a paddle, you just fucking let the fucking current go. You know, it'll take you down current to where you want to go. Should be down creek without a paddle. Stupid expressions. All right, here we can cross multiply. That's my version of saying fuck fractions here. When you have them written as a proportion, this is what happens. We should note that the bottoms can't equal 0. Which means C cannot equal -7. Which makes sense, current can't be negative anyways, that's just fucking stupid. It would be current in the opposite direction. And then 7 minus C equals 0 says that 7 can't equal C. That makes sense, so we don't want the current equal to 7 miles an hour. That's our bad juju numbers. All right, what do we get if we fucking solve this out? 210 minus 30C equals 84 plus 12C. 30C. Did I do that right? Never know, I fucking wrote 17 earlier. And I started to write 3C rather than 30C. You always gotta fucking make sure Jones is up here doing the right shit. Believe it or not, I'm not drinking. All right, so we start combining some shit. I want to get my C's together.
30C.
I'm gonna move the 30C because I like ending up with positive coefficients. So I'm gonna move 30C. I like that. That's a good choice. Which means I can move 84 to the other side at the same time. 210 minus 84, I believe, is 126. And over here, I got 42C. Divide by 42, and that looks like it's gonna round, go in nice and even. C equals 3. And our distance was in terms of miles, and our time was in terms of hours, so this is MPH, miles per hour.
Oh, wait, there's more.
Have I finished the question?
Yeah.
I haven't finished the question yet, though, have I? I only answered half of it. How long were we going? Or no, yeah, how long were we going? Well, now let's just come back and pick one of these. In fact, I like the minus one even better than the. We should go back to the very initial equation now, just to make sure I didn't fuck up. So T times 7 minus C equals 12. So T times 7 minus 3 equals 12. Or T equals 12. So T equals 3 hours. Yeah. Let's see if that makes sense. Does it make sense? Let's look at the 7 plus C times T equals 30. If we went with the current for 3 hours. And we went for 3 hours like that, this should hold true. Because we had current equals 3 and time equals 3. This is 10 times 3 equals 30. We did get that. Any questions? Let's call that a wrap for today. Yeah, a couple minutes early. Does anybody want me to stick around for office hours? Because we can stay in here, but okay.